Hello everyone. Let's continue our course. In these sections, we will discuss the handover procedures. First, let's look at the handover procedures overview. Before the handover here, UE sending the traffic to the core network, and then finally the traffic will go to the internet. And also UE is performing the downloading from the internet. Here, in the downlink, the traffic first from the internet sent to the SGW, then from SGW sent to the eNode B, then from eNode B sent to the UE. In the uplink directions, the traffic from UE to the eNode B, then to the SGW, then to the internet. When UE is moving from this directions to this directions, UE towards to the target eNode B. Here, the source eNode B will build a direct channels to the target eNode B. The source eNode B first make the handover decisions, ask the target eNode B to prepare the resource, and also set up a direct channel between these two eNode Bs over the X2 interface. If the target eNode B have enough resource, then we will start to execute the handover. During the handover executions, the traffic in the uplink from UE to the target eNode B, then go to the SW, then go to the internet. But in the downlink, because our paths haven't been changed, the downlink traffic go from the internet to the SW. Then from SW still go to the source eNode B, because here SW, it doesn't know the user already hand over to the target eNode B. So still send the downlink traffic to the old eNode B. Then the source eNode B, which is the old eNode B, still forward the traffic to the new eNode B. Then the new eNode B send the traffic to the UE finally. At the handover complete procedures, here, MME were involved in these procedures. MME here control the signaling. MME will tell the SW and the target eNode B, ask them to change the path. In the downlink traffic, the internet send the traffic to the SW. Here, we change the path here. SW will no longer send the downlink traffic to this eNode B. SW will send the traffic to the new eNode B, and the new eNode B will forward the downlink traffic to the UE. And after the handover, and this is the traffic flows. Both uplink and the downlink traffic will go from UE to eNode B and SW and the internet. Here, this is a signaling flow for the intra-eNode B handover. Intra-eNode B handover, which means before the handover, the UE stay in this eNode B, and after the handover, UE will stay in the same eNode B. The source cell and the target cell belong to the same eNode B, and this is the intra-eNode B handover. First, UE will send the measurement report to the eNode B. This measurement report is sent by the UE. Actually, before the measurement report, UE will perform the measurement. UE will measure the neighbor cells. If some of the neighbor cells match the criterion, UE will send the report to the eNode B. And the eNode B received the report. eNode B will start the handover decisions, perform the handover or not. And also eNode B will check the remaining resource in the target cell to see if there is enough resource in the target cell to accept these new users. If the new cell where the UE want to go has enough resource, the eNode B will send the handover command to the UE. Here, the handover command we can see is RC connection reconfiguration message. RC connection reconfiguration message is also used in some other scenarios. For example, if UE want to set up a default barrier or dedicated barrier, eNodeB will allocate the radio resource for the UE. And eNodeB also will set up the SRB2 and the DRB. And in that way, eNodeB will send RC connection reconfiguration also. But that RC connection reconfiguration is for the radio resource allocation for the SRB and the DRB setup. But here, this RC connection reconfiguration is used for handover command. How we distinguish RC connection reconfiguration is used for radio resource allocation or handover. We must base on the information element included in the message. Here, this RC connection reconfiguration, they have this important IE, information element, which is mobility control info. If we find this message, this information element in the RC connection reconfiguration, which means this RC connection reconfiguration is for the handover command. UE receive the handover command, then UE will start the handover. UE will disconnect the connections with the old eNodeB and build new connections with the new eNodeB. But in this case, the old eNodeB and the new eNodeB is the same. After UE build the new connections with the new cell, UE will send this complete message to the new cell, RC connection reconfiguration complete message. After the eNodeB receives this complete message, we will consider the handover procedures is complete successfully. Then, after the handover, the eNodeB will send RC connection reconfiguration message to the UE again. This RC connection reconfiguration message here is not used for handover command. Also, is not used for the radio resource allocation, such as the SRB and the DRB setup. This RC connection reconfiguration is used for measurement control. We can see the key information element inside this message. The key information element is the measurement control. This measurement control message is used for telling the UE what is the neighboring cell configuration in the new cell and what is the criterion for the measurement. Because after the handover, UE will move to the new cell. Maybe in the new cell, we have different configuration for the neighboring cell, and also maybe we have different configuration for the measurement criterion. So we must send this message to the UE, update all of this information on the UE side. After UE receives this measurement control message, UE will send the RC connection reconfiguration complete message to the eNodeB. Okay, this is the procedures for the intra-eNodeB handovers. Thanks for watching.